Hello everyone, good evening. So here we will solve some more JEE Mains previous year questions on the chapter Simple Harmonic Motion. Any doubts if you have in any steps, then please write that in the comments so that we can give more priority on it. And please install our Sapience education application also, where we shall upload some important questions in every chapter of physics, which shall be obviously helpful for the exam. So here it is told that simple uh, pendulum in small oscillations to place r height above Earth's surface as time period t1 equal to 4 seconds. T2 would be its time period if it is brought to a point which is at a height 2r from the Earth's surface. Choose the correct relation in T1 and T2. So here that the time period that is given as 2 pi root over L by G. Now the G value at any height, it means T is inversely proportional to root G. Now G, as you know, G is equal to Gm by R plus H whole square, which is the value of G at any height. And Gm I can take it is Gr square. So it is G R square by R plus H whole square. Now G1, I can say T1 that is equal to 2 pi root over L by G1, where G1 will be equal to G, which is the value of G at the Earth's surface. G into R square by R plus H is R height at the Earth's surface. This R is the radius of the Earth whole square. So this is G R square by 2R whole square, which is 4R square. It is G by 4. And similarly, T2 will be equal to 3 by root over L by G2, where G2 is the value of G at a height 2R from the Earth surface. So G into R square by R plus 2R whole square, R plus 2R whole square. So it will be G R square by 3R whole square, which is 9 whole square. It is G by 9. So now, therefore, from here you can see that T1 by T2 that is equal to root over G2 by G1. So G2 by G1. So now therefore T1 by T2 that will be equal to root over G2 that is G by 9 divided by T2 is G by 4. This is equal to root over 4 by 9 is equal to 2 by 3. Therefore, I can say 3T1 that is equal to T2. T1 is equal to T2. So option A is the correct answer. So if here it is told in simple harmonic motion, the total mechanical energy of a given system is E. If mass of the oscillating particle P is doubled, the new energy of the system for the same amplitude is simple harmonic motion. The total mechanical energy of the system is E. So E is equal to the kinetic energy plus the potential energy. If mass of the oscillating particle P is doubled, then the new energy of the system of same amplitude will be. So the kinetic energy plus the potential energy that is given as half k into a square, where there is maximum extension will happen when x equal to a, and then the kinetic energy will become 0. So the total mechanical energy is half k a square. Now the amplitude is kept same. the mass is being doubled. And we know that half m v square. V square is omega square into a square minus x square plus half kx square. Now the so actually half m omega square is equal to k, which is equal to half k a square, which is equal to half m omega square a square. Now omega is equal to root over k by n. So if mass is double, then the frequency also will change. So the new frequency will be root over k by 2 1 in that case. And omega dash square that is k by 2 1. And mass is also 2 1. So 2 1 and 2 m will get cancelled. So the total mechanical energy is independent of the mass of the oscillating particle. It is only dependent on the spring constant K. So hence the same energy will be obtained. So option D is the correct answer. Here it is told a simple pendulum of length 1 meter and has a wooden bob. Its length is L. And it is having a wooden ball of mass 1 kg. It is struck by a bullet. It is struck by a bullet of mass 10 power minus 2 kg, moving with a speed of 2 into 10 power 2 meter per second. The bullet gets embedded into the bob. The height to which the bob rises before swinging back. It is moving with this machine. The bullet gets embedded into the bob. Let's say this mass is capital M, mass is small m. So then the entire system will go up to a height of h, and then it will return back. So that height has been asked. G is 10 meter per second square. Now here you can say that we can conserve the mechanical energy of the system. I can say the initial kinetic energy, or I can say the work done by all forces equal to change in kinetic energy, or I can say the here the kinetic energy of the system will become 0. So the loss in kinetic energy that will be equal to the gain in potential energy of the system. So therefore the kinetic energy loss that will be equal to half m into u square. That is equal to the potential energy gain, that is m plus m into g into h. This h we have to find out. Now h will be equal to mu square by 2m plus m into g. Therefore, the height to which it will rise upward, that is the mass, which is 1 kg into u square, is 2 into 10 power 2 whole square divided by 2 into g, that is 10 into m plus n. M is 10 power minus 2 plus it is 1. This will be 4 into 10 power 4 divided by 20 into 1.01. This is, you can say 40 into 10 power 3. So 22 is a 40. It's approximately 2 into 10 power 3. M is actually not 1. M is 0, 10 power minus 2. This will be strong. Small n is 10 power minus 2. So it is 4 into 10 power 4 into 10 power minus 2 divided by 20 into 1.01. So this will be 4 5s are 20, and this is 100 by 5, which is 5 is of 10, 20. Okay, but here we cannot conserve the energy, since why there will be a energy loss during the collision, since why it is an perfectly inelastic collision will happen, since why the bullet gets embedded into the top. So we can do conservation of momentum. Momentum we can conserve. Momentum we can conserve. So that will be for mu, that is equal to m plus m into v. After collision, the bullet and the ball will move with the common velocity, that is v. So v will be m, that is 10 power minus 2 into 2 power 2 into 10 power 2 divided by m plus m, which is 1.01. So this velocity unit is approximately 2 by, that is approximately 2 only. Now therefore, the height to which it will rise, so that will be the initial kinetic energy, the loss in kinetic energy equal to the gain in potential energy. So the loss in kinetic energy, that is half m plus m into v square, and that is equal to m plus m into gh. M plus m will get cancelled, so it should be equal to v square by 2g, which is v square, that is 4 square, which is 2 into 2 by 2 into 3, that is 10. So it will be a will cancel, so it will approximately 0.2 meter. So till 0.2 meter height it will rise. So option A is the correct answer. So it means that after the collision we can conserve the energy, but uh, before the collision takes place and after the collision takes place, we cannot conserve the energy, since why during the inelastic collision, some kinetic energy loss will take place. Then here is told uh, a particle of mass 0.5 kg executes simple harmonic motion under the force minus 50x. The time period of oscillation is x by 35 seconds, and the value of x is value of x will be 100. So t, as you know, t is equal to 2 pi by omega, and from here you can see that f is equal to minus ma, and acceleration is omega square x, which is minus m omega square x. So therefore, I can say m omega square, that is equal to 50 here, and it's 0.5. So 0.5 into omega square, that is 50. So omega square is equal to 100. So omega should be equal to 10. Omega is 10. So the time period, that will be 2 pi is 2 into 22 by 7 by 10. So this will be 2 into 22 by 7 by 10. So the 10 to 11 is 22. So it is 22 by 35. So it means the required value of x should be 22. Here it is told the position, velocity, and acceleration of a particle executing simple harmonic motion are found to have magnitudes 4 meter, 2 meter per second, and 16 meter per second square. At a certain instant, the amplitude of the motion is root x, where x is. So this will be the position, that is 4 meter, and the velocity, that is 2 meter per second, and the acceleration is 16 meter per second square. A certain instant. So we know that velocity is omega root over a square minus x squared. Acceleration is omega square x. The amplitude of the motion has been asked. Amplitude is root x. Now therefore, E, that is 2 is equal to omega root over a square minus 4 square, and acceleration, that is 16, that is equal to omega square into x. It's 4. So root x, so here we can take it as x. It's not, suppose it's not. So it's not. So therefore, omega square, that will be equal to 4 omega plus 1. So omega is 2 radian per second. Therefore, we can set 2 equals to omega is also 2. So 2 is equal to 2 into root over a square minus 4 square. So a square root over a square minus 4 square, that is 1 square, that is 1. Therefore, a square will be equal to a square is equal to 17. The amplitude would be equal to root over 17. So root amplitude is stored in root x, so x will be equal to 17. 17 is answer. And here it is told an object of Mass 0.2 kg execute simple harmonic motion along the x-axis with a frequency mu that is 25 by pi hertz. Right. Mass is 0.2 kg. Execute simple harmonic motion along the x-axis with frequency this much hertz at the position x equal to 0.04 meter. The object has kinetic energy which is 0.5 joule. The potential energy which is 0.4 joule. At okay, potentially the amplitude of the oscillation is so now we know that k is equal to m omega square. Therefore, m into 4 pi square into mu square. So this will be m that is 0.2 whole square into 4 into pi square into mu square that is 25 square by pi square. 0.2 whole square that is 0.04 into 4 into 25 that is 100, 100 into 25 that is 2500. So this will be 25 into 4 again that is equal to 100. So the value of this spring constant K that is equal to 100 Newton per. Then you know that kinetic energy that is equal to half m omega square into a square minus x square, since it is half m d square. Then potential energy is half k x square. Then their sum is equal to half k a square. Therefore, the sum of the kinetic energy plus potential energy is 0.9 joule, that is equal to half k into a square. Therefore, a square will be equal to 2 into 0.9 divided by k. K, which is 100. So this is going as 2 9s of 18. 18 by 1000. This relation. Can say potential energy that is 0.4 that is equal to half k 100 into x squared. X is sorry 0.2 x squared that is wrong 0.2 into this is into 0.2. So this will be 250 into 2 that is 500 per meter. So P value is 500. So this is wrong. this will be a square, that will be equal to 2 into 0.9, that is 1.8, divided by k, that is 500. So this is 18. So in centimeter it is asked. M into omega squared 4 pi squared squared. So 25 4 the 100, 2500 into 0.2, that is 250 into 2 is 500. Now we can say 0.4, that is the potential energy, that is equal to half k into x squared. Is 0.05 square. Um, Omega is K is 500 Newton per meter. Therefore, here we can see that half k square, which is the total mechanical energy, that is kinetic energy plus potential energy, which is equal to 0.9 joule, and that is equal to half k square. And k we have found it as m omega square, which is m is 0.2 into 2 pi nu whole square, which is 0.2 into 2 pi into 25 by pi whole square, which is 50 square, which is 2500 into 0.2, which is equal to 500 Newton per meter. This is half into k into a square. So therefore, I can say a square, that will be equal to 2 into 0.9 divided by 500. 2 into 0.9 divided by 500, which is 1.8 divided by 500. 18 by 5,000 is 18 by 001. So therefore, amplitude will be 3 by 50 in meters, but in centimeter it is asked, which is 3 by 50 into 100 centimeter, which is 6 centimeter. So 6 is the answer. And here it is told particle is doing simple harmonic motion of amplitude 0.06 meter, and time period is 3.14 second, which means it is pi seconds. The maximum velocity of the particle is, so you know that the maximum velocity, that is equal to k omega, since the velocity at any point x, that is given as omega square root of a square minus x square. So the maximum maximum velocity will be a omega. So it is 0.06 into omega, which is 2 pi by t. So this will be equal to 0.12, which is your 0.12 meter per second, which means it is 12 centimeter per second. Just 12 centimeter per second. Here we can say the displacement of a particle executing a sequence is given by x equal to 10 sine omega t plus pi by 3. Here, the time period of the motion, that is 3.14 seconds. The velocity of the particle at t equal to 0 is dash meter per second. Velocity has been asked. Velocity of the particle at t equal to 0 has been asked. So therefore, amplitude is 10 meters. So at so v will be equal to dx by dt. V will be equal to, that is 10 omega into cos omega t plus pi by 3. So therefore, v at time t equal to 0, that will be equal to 10 omega into cos pi by 3. Cos pi by 3 is cos 60 degree, that is half. So it is 5 omega. Half into 10, that is 5. 5 into omega, which is 2 pi by t, t is also 5. So it is 10 meter per second. 10 is the answer. Here it is told a mass m is suspended from a spring. Mass m is suspended from a spring, and the system oscillates with a frequency f1. The frequency of oscillations if your mass 9m is suspended from the spring is f2. So then here the frequency, as we know, frequency is equal to 2 pi root over m by k. Means we know that m omega square is equal to k, so omega is actually root over k by m. So 2 pi by omega of, if we do frequency, this is actually the time period. So this is 2 pi by omega, that is frequency, as you know, that is omega by 2 pi. So this is 1 by 2 pi root over k by m. So actually we have the same spring, it is suspended from the same spring. So the spring constant will not change. So therefore, if the frequency is inversely proportional to root m, so therefore I can say f1 by f2, that is equal to root over m2 by m1, which is equal to root over 9m by m. So that is root over 9, that is 3 by 1. So the value of f1 by f2 is 3. So 3 is the answer. Then here it is told particle performs simple harmonic motion with amplitude A. Amplitude is A. If its speed is increased to 3 times at an instant, when the displacement is 2a by 3, speed is increased to 3 times. Then the speed is increased to 3 times. Then v will be increased to 3 times of v at x. Then the new amplitude of the motion, which is a dash, that will be equal to n a by 3. And the value of n will be published. So at x equal to 2a by 3, the velocity actual velocity that is given as omega root over a square minus x square, which is 4a square by 9. Is omega root over 5a square by 9, which is root 5 by 3 into a omega, root 5 by 3 into a omega. Now the new velocity at x equal to a by 3, that is actually given as e dash, that is equal to root 5 a omega, which is 3 times of v. So now that value, so the amplitude will change. So E dash, that is, I can say that is equal to omega. The frequency will not change; it will remain the same, which is root over a dash square minus x square, which is 4a square. This is root 5 into a omega. It is equal to omega to root over a dash square, which is the a dash is the new amplitude, which is na by 3. So minus 4a square by 9. So omega will get cancelled, then we can square both sides. So it is 5a square, that is equal to a dash square minus 4a square by 9. So therefore a dash square is equal to 5a square plus 4a square by 9. 5a square plus 4a square by 9. So this will be 5 9 45, 49a square by 9. So therefore, a dash, that will be equal to 7a by 3. Since it is the square root of this, square root of 49 by 9 is 7 by 3. So it is equal to given as na by 3. So that therefore the value of n is 7. So 7 is the answer. Then here it is told a simple harmonic oscillator is told that a simple harmonic oscillator has an amplitude A, and a time the amplitude is A, and a time period is 6 pi seconds. Assuming the oscillation starts from its mean position. Oscillation starts from its mean position. The time, okay, let's say we have a spring mass system. So the oscillation starts from its mean position, which is at x equal to c0 only, and the time required by it travel from x equal to a. Means it will travel from x equal to a to x equal to root 3a by 2. Root 3 by 2. This time interval, I can say t1, that is equal to pi by x second. Then x will be that is not. So you know that x equal to it starts from its main position only. It means that at t equal to 0, x was equal to 0 only. Which is so since it was initially at mean position only. So x, I can say it is equal to a sine omega t. So a will be of this form, a sine omega t. So then x will be equal to a, let's say, at time at time t, then it will be at x equal to root 3 by 2 at time t minus t1, t plus t1. Since why it is told that if the time required by 2 travel from x equal to a to x equal to root 3 by 2, a is pi by x second, so that t1 has been asked. So at so I can say a is equal to a sine omega t. So therefore I can say sine omega t, that is equal to 1. So then omega t, that should be equal to pi by 2. And sine pi by 2 is 1. So t, I can say that is equal to pi by 2 omega. And I can say root 3a by 2, that is equal to a sine omega into t plus t1. A will cancel. So now therefore I can say omega into t plus t1, that is nothing but root 3 by 2. So sine theta, if it is root 3 by 2, that then theta should be 60 degrees. Is half. Sine 30 is half, so sine 60 is root 3 by 2. This is 60 degree, that is pi by 3. So t is so t plus t1, that is equal to pi by 3 omega. So therefore I can say t1, that is equal to pi by 3 omega minus t, that is pi by 2 omega. So this value will be, so this will be actually more than pi by 2. It is 2. So it's pi. So we can write this as pi minus pi by 3. Pi minus pi by 3 means this is 2 pi by 3. And sine pi minus theta is equal to sine theta only. So 3 2 pi by 3 omega minus this. So to take the LCM, then it is 6 omega, and 3 2s are 6, to the 4 pi minus 2 3s are 6, it is 3 pi. So T1, that is equal to pi by 6 omega. Pi by 6 omega. Now omega is equal to 2 pi by t. T is 6 pi. This is 2 pi by 6 pi. This is 1 by 3 radian per second. So T1, that would be equal to pi by 2. So it should be equal to 2. It is that when the displacement of a simple harmonic oscillator at third of its amplitude, the displacement of a simple harmonic oscillator is 1/3 of something, means A by 3. The ratio of the total energy to the kinetic energy, that is equal to x by 8, then x will be how much? So the total energy, that is given as half k a square. The kinetic energy is given as half k into a square minus h square. That is a square minus this displacement, let's call it as x1, a minus x1 square. So therefore it is told that half k a square by half k into a square minus x1 square, that is equal to x by 8. So half k will get cancelled. So therefore I can say a square by a square minus x1 square, that is a square by 9. That is equal to x by 8. So it means a square by is 8 a square by 9. That is equal to S square is going to cancel. So x by 8 is equal to 9 by 8. So x is equal to 9. So the value of x is 9. 9 is the answer. So, where it is told that particle executes simple harmonic motion with amplitude 4 centimeter, which means 0.04 meter. At the mean position, the velocity of the particle is 10 centimeter per second. Means the maximum velocity is obtained at the mean position, which is a omega. That is equal to 10 centimeter per second, or I can say that is 0.1 meter per second. The distance of the particle from the mean position when its speed becomes 5 centimeter per second is root alpha centimeter. So at x equal to root alpha centimeter, the velocity is 5 centimeter per second, means it is a omega by 2. So then alpha will be how much that we have to find out. So now you know that V is equal to omega root over a square minus x square, and that is equal to a omega by 2. Then you can say omega will cancel out. So a square minus x square, that will be equal to a square by 4. V square both sides. Then x square will be equal to 3a square by 4, means a square minus a square by 4. Therefore, x will be equal to root 3a by 2. It means it is root 3 by 2 into 4 centimeter. Means it is 2 root 3 centimeter, or I can say it is root over 12 centimeter. Means therefore root alpha, that is equal to root 12. So therefore alpha is equal to 12. So 12 is the answer. And here it is stored in a linear simple harmonic motion. Restoring force is directly proportional to the displacement. Restoring force is directly proportional to the displacement. The acceleration and the displacement are opposite in direction. Of course, it is true since y is minus omega square x. The velocity is maximum at the mean position. This is also true. But choose the correct answer from the options. And the acceleration is minimum at the extreme points. No, that is wrong since acceleration is maximum at the extreme points. So at the mean position, the velocity is maximum. So C is true, B is also true, and A is also true. So A, B, and C. So option C is the correct answer. It is told particle executes a system of amplitude A, the distance from the mean position where its kinetic energy becomes equal to its potential energy. So you know that kinetic energy is equal to half k into a square minus x square, and potential energy that is equal to half k x square. So we have to find the distance x at which kinetic energy and potential energy are equal. So if these two are equal, then I will say half k x square minus x square, that should be equal to half k x square. So half k I can cancel out. So I can say a square will be equal to 2x square. So x will be equal to a by root 2. So a by root 2. So option A is the correct answer. Then here it is told which graph represents the difference between total energy and potential energy of a particle executing a system as its versus its distance from the main position. So we know that the total energy is half k a square and the potential energy is half k x square. So if we subtract these two, then we get obviously the kinetic energy, that is half k into x square minus x square. So It's so this kinetic energy versus x graph we have to find out. Since we have to find out the graph of the difference in between total energy and potential energy versus the its distance from its mean position, that is x. So obviously option A is the correct answer. Since at x equal to 0 it will be maximum, and at x equal to plus or minus it will be 0. And since it is a quadratic function of x, so it will have a parabolic shape. The graph will be a parabola. So of course option A is the correct answer. Then it is told a particle is executing simple harmonic motion. The ratio of the potential energy and kinetic energy of the particle when its displacement is half of its amplitude will be. So the ratio of the potential energy and kinetic energy when the displacement is half of its amplitude when x equal to a by 2, that will be 1/32. So the potential energy that will be given as the potential energy, that is half kx square. Its displacement is half of the amplitude, half k into k by 2 whole square, which is half k into a square by 4. The kinetic energy, that is half k into a square minus x square, a square by 4, which is 3 by 4 into half k square. So therefore, the ratio of the potential energy and kinetic energy, that is equal to half k a square by 4 is to half k a square into 3 by 4. So half k square will cancel, 4 also will cancel. So this is 1:3. So option D is the correct answer. Then here it is told the variation of kinetic energy of a particle executing simple harmonic motion with the displacement x starting from the mean position to extreme position is given by variation of the kinetic energy with the displacement x. Kinetic energy with the displacement x starting from mean position to extreme position P is given by kinetic energy that will be equal to simple harmonic motion. X. So kinetic energy versus x. And so we know that kinetic energy that is given as half k into a square minus x square. So starting from the mean position to a. So obviously option C is the correct answer. Since it is a quadratic function, so the graph will have a parabolic shape. At x equal to 0, it is maximum. At x equal to a, it is 0. Then it is told a particle executes a section of amplitude a along the x-axis at p equal to 0. The position of the particle is x equal to a by 2. and it moves along the positive x-axis. The displacement of the particle in time t is given as x equal to a sine omega t plus delta, then the values of delta. So x equal to a by 2. So at t equal to 0, x equal to a by 2, and velocity is greater than 0. Means it is moving along positive x-axis. So therefore, x equal to a sine omega t plus uh, delta. So the value of delta we have to find out. So at t equal to 0, x will be equal to a sine delta, and that is equal to a by 2. So a cancels. Sine delta is half. So it means that delta I can say that is equal to pi by 6. So delta can be pi by 6 also, or delta can be pi minus pi by 6 also, which is pi by 6. We have to find out. So velocity is 0. So velocity will be dx by dt, that is equal to a omega cos omega t plus delta. At t equal to 0, v will be equal to a omega cos delta. Now cos delta should be greater than 0. Then only v will be greater than 0. So cos delta is greater than 0. It means that delta should be, so you know that the cosine graph is somewhat like this. So it should be from 0 to pi by 2, or from 3 pi by 2. It can be more than 3 pi by 2, then 5 pi by 2. This is why from pi by 2 to 3 pi by 2, it is negative. 3 pi by 2 by this is 2 pi, it's 5 pi by 2. So it should be in the range 0 to pi by 2 only. So it means that now 5 pi by 6, it is more than pi by 2. Means why 5 pi by 6 is more than 3 pi by 6. So it means that delta should be equal to pi by 6 and not 5 pi by 6. Since why if it is 5 pi by 6, then cos 5 pi by 6 will be negative, since cos 5 pi by 6 is equal to minus root 3 by 2. So hence we should take the value of delta as pi by 6. Option D is the correct answer. Now, for particle P revolving around the center of its radius of circular path r and angular velocity of omega, as shown in the below figure, the projection of OP in the x-axis at time t. Okay. And particle P is revolving around the center, and the projection of OP. So here initially this is R, so this is X. So at any time P, this is X. So I can say that X is equal to R. If this is theta, and then we say angular velocity omega, so theta is equal to omega t. So x equal to theta is equal to omega t plus pi by 6. Omega t plus pi by 6. Since y at t equal to, so x will be equal to r sine theta, it is r cos theta, so it is omega t plus pi by 6. That's why initially at t equal to 0, the projection of OP on the x-axis, that will be r cos pi by 6 is equal to root 3 r by 2. So x should be equal to r cos omega t plus pi by 6. So option C is the correct answer. So it means the angle theta should be this from here to here, and theta is equal to omega t plus pi by 6. Since why this angle will be equal to omega t. Here it is told a mass M is attached to two strings as shown in the figure. The spring constant of two springs K1 and K2, K1 and K2 for the frictionless surface. The time period of oscillation mass M is. So now, if it gets displaced by x, if the mass M gets displaced towards the right by x, then the force acting on the mass, that will be equal to this F1 plus F2. F1 plus F2, that will be equal to the net force, which is K1x. There also some compression will be there. So K1x plus K2x. K1 plus K2 into x, which is the net force on it. So it means the equivalent spring constant, that will be equal to K1 plus K2. And we know that the time period of oscillation of mass is given as 2 pi root over m by k. So here k will be K1 plus K2. So 2 pi root over m by K1 plus K2. So option A is the correct answer. We have to store that. Use the correct length m versus square of the time period t square graph for a simple pendulum executing its simple harmonic motion. Versus square of the time period for a simple pendulum execution. So for a simple pendulum, you can say t equals to 2 pi root over L by G, 2 pi root over L by G. So therefore, I can say t square, that should be equal to 4 pi square into L by G. So therefore, t square versus L. T square versus L graph has a different slope. So it will have slope equal to 4 pi square by G, which is a constant. So it means the slope is constant. So it means it will be a straight line passing to the origin. So therefore option D is the correct answer. It's told the maximum potential energy of a block executing a simple harmonic motion is 25 Joule. A is the amplitude. The amplitude, and at A by 2, the kinetic energy of the block is. So at x equal to A by 2, you have to find how much is the kinetic energy of the block. Therefore, kinetic energy, that will be equal to half k into a square minus x square, equal to half k into a square minus a square by 0. So therefore, that is equal to half k into a square by 4. G of the flow. So the maximum potential energy is given as half k a square. So half k a square value is 25 joule. So therefore, the kinetic energy at x equal to a by 2 will be equal to, so that is 3 by 4 into half k a square, which is equal to 25 times. So it is 3 by 4 into 25 times. So it is 75 by 4 equal to 4, 4, 32, 18.75 G. 18.75 G is the required kinetic energy of the block. So option C is the correct answer. Okay, so here it is told that for a simple harmonic motion in a mass spring system shown, the execution does when the block, mass of the block is 1 kg. Mass of the block is 1 kg, the angular frequency is omega 1, and the mass of the block is 2 kg. And the frequency is omega 2. And the ratio omega 2 by omega 1 is. I know that omega is root over k by m. And sorry, acceleration, which is acceleration is minus omega square x. Force is equal to kx. So k by m, that is equal to omega square. Omega square is k by m. So omega is directly inversely proportional to root m. So I can say omega 2 by omega 1, that will be equal to root over m1 by m2. M1 is 1 kg and omega 2 is 2 kg. So this will be 1 by root 2. Option A is the correct answer. Then it is told a particle executes simple harmonic motion between x equal to minus a and x equal to plus a. If time taken by particle to go from x equal to 0 to x equal to a by 2 is 2 seconds, then the time taken by particle in going from x equal to a by 2 to a is. So suppose if I assume that the motion of motion, the equation of motion of the system is a sine omega t. So at t equal to 0, it is at x equal to 0, and at a by 2, it will come to a by 2 at the time. A will cancel. So omega t, that should be equal to sine theta is half at pi by 6. So at t equal to uh, at t equal to pi by 6 omega, it will reach x will be equal to pi by 2. So this is equal to 2 seconds. So pi by 6 omega is 2 seconds. So therefore pi by omega value is 12 seconds. Now the time taken by it to go from x equal to a by 2 to a is, so it will reach a at a sine omega t t1, suppose. So then sine omega t is 1. Omega t1, that should be equal to pi by 2. So therefore t1 is pi by 2 omega. So here, so t1 will be equal to 6 seconds. So at t equal to 6 seconds, it will reach x equal to a by 2. At x equal to a, it will reach, and at t equal to 2 seconds, it will reach x equal to a by 2. So therefore, the time it will take to go from x equal to a by 2 to a, that is 4 seconds. So option A is the correct answer. Then it is told t is the time period of simple pendulum on the Earth's surface. Its time period becomes xt when taken to a height r of the Earth's surface, then the value of x will be. So t is the time period of simple pendulum on the Earth's surface. So on the Earth's surface, the time period is t seconds. T is equal to 2 pi root over L by G. and time period is xt when taken to a height r. R is equal to radius of earth, then the value of x will be. So the value of g at a height h, that is given as g into r square by r plus h square. So this will be equal to g into r square by r plus r, so 2r whole square equal to g by 4. So g dash is g by 4 at a height equal to r of the person. So xt will be equal to 2 pi root over L by g by 4. So this will be equal to root 4, that is twice 2 into 2 pi root over L by g. So it is equal to 2t. So x is equal to 2. So option C is the correct answer. Here it is told at a given point of time, the value of displacement of a simple harmonic oscillator is given by y equal to a cos 30 degree. Its amplitude is 40 centimeter, and kinetic energy at that time is 200 V. The value of force constant is 1 into 10 power x Newton per meter. The value of x is. So we know that kinetic energy at any time is given by half k into a square minus x square. A square minus y square. So now y is equal to a by 2, means a cos 30 means root 3 by 2. So this will be y square will be 3a square by 4 is 3 by 4 into amplitude, which is 40 centimeter, 40 and 40 by 100 into 40 by 100. So this will be 12 by 100. So this is 0.12. So half into k to a square. A square is 0.4 whole square minus 0.12. Amplitude is 40 centimeter, means amplitude is 0.4 meter. So kinetic energy is 200. So 200 is equal to half into k into 0.4 into, I can say, 0.4 minus 0.3 is 0.1, means it is 0.04 by 2 k, that is equal to 200. So 2 use of 4. So k will be equal to 200 by 2 by 100. So 200. So k is equal to 10 power 4 Newton per meter. So the value of force constant is 10 power 4. So x will be equal to 4. 4 is the answer. Then it is told a rectangular block of mass 5 kg is attached to a horizontal spiral spring. Attached to a horizontal spiral spring executes simple harmonic motion of amplitude 1 meter and time period is 3.14 seconds. The maximum force exerted by spring on the block is. So the maximum force exerted, that will be equal to when x is maximum, which will be same as the amplitude. So the maximum force is equal to K is K, that is K, as you know, K is equal to M omega square, or T is equal to 2 pi root over M by K. K will be equal to M, that is 5 kg into omega square, which is 2 pi by T. 2 pi by T is also pi whole square. So this is 4, 5, 0, 20. 20 Newton per meter. So this is 20 Newton per meter into the amplitude, which is 1 meter. So the maximum force exerted is 20 Newton. So 20 is the answer. A simple pendulum of length 100 centimeter and rod of mass 250 grams exhibiting a switching of amplitude 10 centimeter. Maximum tension in the string is found to be x by 40 Newton, the value of x is. Now, the maximum tension, so this is the, at any angle theta, the tension is supposed T, this is mg. So this will be mg cos theta. I will say T minus mg cos theta, that is equal to m omega square L. So this centripetal force, that is the length of the string. The angle theta is small. The amplitude is 10 centimeter, length is 100 centimeter. So I will say T equal to tension mg cos theta plus m omega plus m omega square L plus m omega square L. We say m v square by L, v square by L. We can say half m v square minus, okay, half m u square minus half m v square, which is the loss in kinetic energy. Here the speed is u, here the speed is v, and that is equal to mg into h. H is equal to L into 1 minus cos theta. L minus L cos theta. So therefore, E square, I can say, that is equal to U square minus 2GL into 1 minus cos theta. So T will be equal to mg cos theta plus n by L into this. So plus mu square by L minus 2mg into 1 minus cos theta. Equal to mu square by L minus 2mg plus 3mg cos theta. This is the tension. So as we know, angle theta, if it increases, then cos theta will decrease. So if theta decreases, then cos theta will increase. So tension is maximum when the angle theta will be 0 degree. Then the maximum tension will be, so therefore I can say that therefore the maximum tension that will be equal to mu square by L minus 2 mg plus 3 mg. That is mg. So mg minus mu square by L. Mg plus mu square by L. Plus mu square by L. And, then what will be u that we can find out? Therefore, now half mu square minus 0, that is the loss in kinetic energy, that is equal to mgh mgl into 1 minus cos theta. Now, the value of cos theta when the amplitude is 10 centimeter, cos theta that will be sin theta, that is tan theta, that is 10 by, I can say sin theta will be equal to 10 by 100. Amplitude is 10, it is total. So sin theta is 1 by 10. So cos theta that would be equal to root over 1 minus sin square theta, root over 1 minus 1 by 100. So that is 99 by 100. So it is root over 0.99 is approximately 1. You can say maximum tension means maximum force. Cos theta is mg, t cos theta is mg, t sin theta is cos theta is mg, and t sin theta is k into a. Now k, which is the force constant, k is equal to m omega square. K is equal to m omega square. M into root omega square is g by L. So mg by L is mg by L. So therefore, the maximum force that will be obviously mg by L into a. Therefore, now the maximum force is acting towards the center. That is T sine theta. Sine theta, that is 1 by 10. So therefore, now T sine theta, which is the maximum tension into sine theta, that is equal to mg by L into A. Sine theta is 1 by 10. Equal to m, that is 0.25 into g, that is m by L, that is 0.1 into A, that is 0.01. Oh, sorry, 0.1 meter and 100 centimeters, 1 meter. So this will be 1 P max, that will be equal to 2.5. 2.5 is equal to x by 40. Therefore, x will be equal to 25 into 4, that is 100. So x, the value of x is 100. That is the answer. So the maximum tension in the string is found to be x by 40 newtons, so x is 100. The maximum tension will be m, that is 0.25 into g, that is 10 into a, that is 0.1 by L, that is 1. So this will be q will be equal to 2.5. 2.5 is equal to x by 40, so x will be equal to 10. Then it is told the amplitude of a particle executing SHM is 3 centimeter. The displacement at which is kinetic energy will be 25% of them more than its potential energy is. So we know that the potential energy is half kx square, and kinetic energy, that is told 25% more than this, means it is 125% of the potential energy, which is 1.25 into half kx square. That is equal to half k into a square minus x square. Then you have to find the displacement x at which this will happen. So therefore, I can say half k into a square minus x square, that is equal to half k x square into 1.25. So half k will get cancelled. I can say a square minus x square, that is equal to 1.25 x square. Therefore, 2.25 x square, that is equal to a square. Therefore, x square, that will be equal to a square by 2.25. Therefore, x will be equal to a by 1.5. So this will be equal to 2a by 3. So 2 by 3 into the amplitude. Amplitude is 3 centimeters. So this is 2 centimeters. So the required displacement at which its kinetic energy will be 25% more than its the potential energy will be 2 centimeters. And it is told the velocity of a particle executing SHM varies with its displacement x as v square equal to 50 minus x square. The time period of oscillations is x by 7 seconds. The value of x is time period of oscillation is x by 7 seconds. Value of x is. So as you know, v square equal to omega into square root of x square minus x square. So here if you take the square root of this, so you will get 2v square that is equal to square root of 50 minus x square. So v square, so 2v, so v will be equal to 1 by 2 into e power 50 minus x square. So therefore, so v equal to omega into root over s minus x square. So therefore here the omega value is 1 by 2, which is equal to 2 pi by t. Therefore the time period of oscillations is equal to 4 pi. Is equal to 4 into 22 by 7, that is equal to 88 by 7 seconds. Which is equal to x by 7. So therefore x is equal to 88. So 88 is the answer. And here it is told that in the figure given below, a block of mass m 490 gram placed on a frictionless stable is connected to two springs having same spring constant k equal to 2 Newton per meter. If the block is horizontally displaced through x meter, then the number of complete oscillations it will make in 14 pi seconds will be. So it is displaced by x meters. Number of complete oscillations. So here the time period that will be equal to. So here the net force that will be equal to F1 plus F2. That is equal to K1 plus K2, that is 2KH. So the K equivalent that is equal to 2K. That means the equivalent spring constant is 2K. The sum of the two spring constants is equal to 4 Newton per meter. So as you know, the time period is 2 by root over m by k equivalent. So that is 2 by root over m, that is 490 gram, that is 0.49 kg, divided by 4. Or I think so this will be 2 by root over 0.7 by 2, which is 0.7 into 22 by 7. 0.1, so that is 2.2 seconds. So the time period of oscillation is 2.2 seconds. Or I can say that is this is 0.7 pi seconds. 0.7 pi seconds is the time period. So therefore, the number of complete oscillations that it will make, that will be equal to the given time by the time period. So that is equal to 14 pi seconds divided by 0.7 pi. So pi will cancel. So 7 by 10. 7 to the 14. So 20 or 20 complete oscillations it will make. So the answer is 20. Then it is told the general displacement of a simple harmonic oscillator is x equal to a sine omega t. Let t be its time period. The slope of its potential energy u of its time curve will be maximum when t equal to t by beta. Then the value of beta is the slope will be maximum equal to T by beta. So the potential energy for U equal to I, we know that it is half k square. So the slope will be maximum, means du by dt time. So this will be, so U is equal to half k into a square into sine square omega t. So which is, I can say it is half k a square into sine square omega t, means 1 minus cos 2 omega t by 2. So du by dt, that should be equal to 0, and d square u by dt square, that should be less than 0 when the slope will be maximum. Yes, slope is maximum. Slope will be maximum is wrong. So now the slope du by dt, it will be equal to 1 by 4 ka square into d by dt of 1, that is 0, minus this is 4 omega into sine cos d by dt of cos minus sine, so plus omega into sine 2 omega t. So 2 and 2 will cancel. So this is half k square into omega into sine 2 omega t. So this slope will be maximum when so du by dt is maximum at 2 omega t equals to pi by 2. 2 omega t equals to pi by 2, since then sine 2 omega t will be equal to 1. The maximum value of sine 2 omega t we will get, that will be equal to t equal to pi by 4 omega. Now we know that capital T is the time period that is equal, that is given as pi 2 pi by omega, 2 pi by omega. So omega you can write it as so therefore this t equal to pi by 4 omega. So here t I can write it as 2 pi by 8 omega, which is 2 pi by omega by 8, means it is t by 8. So which is given, told that it is t by beta. So therefore the value of beta is 8. So the value of beta is 8. So 8 is answer. And here it is told particle of mass 50 gram executes a simple harmonic motion under periodic force F is equal to minus 25x Newton. The particle attains a maximum speed of 4 meter per second during its oscillation. The amplitude of the motion is. So we know that force equal to minus kx according to the Hooke's law, which is, so since why this type of force only will act when SHM will happen. Okay, so here K is equal to 25 Newton per meter. And so it will attain a maximum speed. So V max, that is equal to A omega. Since speed is A omega, and omega we know that will be equal to root over K by M. This will be root over 25 by M, that is 250 gram, that is 0.25 kg. So omega, that will be equal to 5 by 0.5 is equal to 10 radian per second. Omega is 10, so therefore the maximum speed, that is 4, that is equal to A into omega, that is 10. So the amplitude of the motion is 0.4 meter, means it is 40 centimeter. So the amplitude of the motion is 40 centimeters. So 40 is the answer. So hope all of you understood the solutions of all these questions based on the previous year JEE Mains exam on the chapter Simple Harmonic Motion. There's still any doubts, if you have, please write that in the comments. We shall obviously clarify them in the subsequent videos, and also please install our Sapience Education application, where we shall upload some important homework questions based on the previous year Mains exam on every chapter of physics, which shall be obviously helpful for our exam. So thank you everyone. Bye.